Alright, so far we have been talking about pretty much the atomic level. And so remember that atoms make up everything. The next level would be molecules and compounds. Okay, so our next little video is going to cover what molecules and compounds are and then how they are formed. We're going to talk about different types of bonds. So compounds and molecules are groups of atoms that chemically bond together. And so remember that when atoms don't have a full outer shell, they start to maybe lose or gain electrons, or we're going to see that they may share electrons. And it's all about getting that 8. Okay, atoms want to have 8 electrons in their outer shell. And so that's what is going to lead them to form compounds and molecules. So a molecule, by definition, is any 2 or more atoms bonded together. And then a compound specifically has at least 2 different elements. So in a chemical compound, you should see at least 2 different capital letters. Now there's 2 main types of compounds. We have ionic compounds, and we're going to see that they are formed by ionic bonds. And we'll talk about exactly how that happens in a few slides. And so ionic compounds is an attraction between ions. So we know that ions are charged particles. And what happens is when one atom loses and one atom gains, we now have positive and negative charges and opposites attract. And that's essentially what forms an ionic compound. Now molecular compounds are formed by another type of bond, and these we call covalent. Okay, and so what's happening here is they are sharing covalent or sharing valence electrons, and that's kind of where you get that name from, covalent. They're sharing those valence electrons. And we're also going to see how those are formed and go a little bit in more detail about ionic and covalent bonds. So molecular compounds are held together by covalent bonds. Your ionic compounds were held together by ionic bonds. All right, so now let's talk about exactly how these form. So once again, it's all about the 8 valence electrons. In order to kind of be happy, atoms like to have that full outer shell. And so in many instances, that is going to lead to a transfer of electrons. So I always try to teach my students kind of like key words, and something I need you to remember is ionic is a transfer, ionic is a transfer, ionic is a transfer. So this is the key word to remember for ionic bonds, that the electrons are transferred from one atom to another. And so you've got several different examples over here. There was an example in the last video when we were talking about the valence electrons. But here's probably one of the most common examples because we use this stuff all the time. This is your table salt. And so sodium over here has 1 valence electron. And then chlorine over here has 7. And so sodium can get rid of 1 or it can gain 7. Chlorine can gain 1 or lose 7. And so you can see that it's a lot easier if the sodium just loses that electron, it goes over and joins up with the one on the chlorine. And when that happens, sodium becomes positive, chlorine becomes negative, and then now they are attracted to each other. Okay, so ionic bonds form when the opposites attract. Okay, so the positive and the negative are attracted to each other, and that's how we get the ionic bond. Now, in general, these are not super strong, especially when you put them in water, but when we compare them to the covalent bonds, they are definitely weaker. But they do hold these salts together, and you can see in each instance, one loses and becomes positive, the other gains, becomes negative, and then they attract to each other. Now, covalent, on the other hand, the key word here is sharing. Covalent is a sharing, covalent is a sharing, covalent is a sharing. So that key word is really important. And so once again, covalent, they're literally kind of sharing valence electrons. So in this case, there's not going to be a complete loss or gain. So we're not going to have the formation of ions. We're not going to get charged particles. We're not going to get the positive, negative that attract to each other. Because when they share, they don't completely lose or completely gain, and so they no longer really have a full charge. And so in this case, they share, and that pair just kind of hangs out within the orbitals of both. This is what happens in a water molecule. This is what happens in a lot of your carbon compounds. When we get to macromolecules in a video coming up, those are going to be held by covalent bonds, and covalent bonds are very strong. In both covalent and ionic bonds, they are found like within the molecule or within the compound, and we're going to talk about another type here in a minute. So, ionic bonds are formed from, okay, now we should be able to knock these out because sharing is the word that we need for covalent. And so we either have a transfer of protons or a transfer of electrons. And when it comes to bonding, it's all about the electrons. Remember, the protons don't change. If the protons were to change, we don't have the same element anymore. So it's those valence electrons that get transferred, and that's how we get ionic bonds. All right, now ionic bonds or ionic compounds, when we get them in water, what they will do is they will break apart into those ions. And so we call these electrolytes. And so things, any kind of type of salt, like sodium chloride, here's some other examples, hydrochloric acid. Whenever they are put into water, they what's called dissociate. They break apart into their ionic form. And so you can see these charges within that water. And so they are actually very good conductors of electricity. A lot of times you'll see advertised that drinks have electrolytes. It's because we need these ions for different chemical reactions in our body, and so you need to drink and replenish your electrolytes. Now, if you were to put a compound in water and it does not break apart into ions, then we would call those non-electrolytes, and they are not very good at conducting electricity. So those are going to be things like sugars or alcohols, oils. All of these things have covalent bonds, and so they don't dissociate or break apart into ions in water. All right, so next question, electrolytes. They break apart into ions. They do break apart, therefore they dissolve. They are ionic, and so they are also good conductors of electricity. All right, so far we've talked about ionic bonds are formed by a transfer of electrons. Covalent bonds are formed by a sharing of electrons. And so our third type of bond that we need to discuss is a hydrogen bond. But in order to understand what a hydrogen bond is, we have to understand this term here, polarity. And so polarity comes from the word polar, which means having poles. And so this is related to covalent bonds, okay? Polarity has to do with a bond where electrons are shared. Now, just like in real life, you can share materials, you can share your home, you can share food. But the thing is just like in our daily lives, the sharing may not always be equal. I always give a silly example of me and Dove dark chocolates. I love Dove dark chocolates. And I like to consider myself a pretty nice person. And so if I had a bag of Dove chocolates, I might share one or two with the people that are around me. But I am not necessarily going to give them half of my bag of Dove chocolates because I like them more than they do. And so the same thing happens in a covalent bond, or it can happen in a covalent bond. There are some atoms that just like electrons more. You don't have to know this term, but it's called electronegativity. And so what can happen is, in some covalent bonds, certain regions of the molecule will kind of hold the electrons a little tighter. And so what happens is we have a sharing, but we don't have an equal sharing. Okay, and so we can describe these covalent bonds as either nonpolar or polar. Now, nonpolar is when they are shared equally, and so we don't get poles on the molecule. And polar is when they are shared unequally. And so what happens is the electrons are kind of uneven in their distribution. And what that does is it creates some areas of the molecule to become kind of negative and some areas of the molecule to become kind of positive. And so the unequal sharing is going to lead to partially charged. So these are not ions, they haven't lost or gained, but it creates these partially charged regions or poles. And so they're very, very weak. It's just a slight negative charge or a slight positive charge. And that's what we call a polar molecule. So in nonpolar, they all like the electrons the same, so they share them equally. And so what happens is we don't have any type of poles or partial charges or anything like that. But in a polar covalent bond, some elements like them a little bit more, so they tug them and keep them a little bit closer to that end of the molecule. And so what happens is we get these little weak charges. And so notice it's a partial charge. It's not like an ion where it's a full-on positive or negative charge. We get a kind of negative region here and a kind positive regions there. So they're just kind of these weak charges. And that's what we call a polar molecule. They have positive and negative poles. All right, so a type of bond that results from a molecular compound that shares electrons equally, okay? So we have two important words here. We have sharing, and as soon as we see sharing, we know it's not ionic. We haven't really talked about these yet, okay? And then if they're shared equally, that is what leads to a nonpolar covalent bond. Polar is when they're shared equally. All right, so one of the most common examples of a polar molecule is water. And water is what we consider a great solvent. And what that means is it dissolves other substances really well. You know, it's kind of what we a lot of times refer to as the universal solvent. And when it comes to dissolving and making solutions, like dissolves like, okay? So because water is polar, it dissolves other polar molecules very well. Polar dissolves polar, all right? So things like sugar and things like salts, or things that are either ionic or polar, they dissolve really easily in water. Now, nonpolar substances do not dissolve in water. If they don't have those partial charges, then they don't get all surrounded by the little water molecules like these over here will, and so they don't break apart in the water like the polar molecules do. And so a good example of this is oil, any type of fat, okay? Oil and water don't mix, and so what happens if it's nonpolar is it just kind of stays like it is, and it doesn't break apart, and they just separate. So because water's polar, it dissolves other polar molecules well. All right, now I did change this question up a little bit. In the packet it says if salt, and salt is actually an ionic compound, and so I didn't want it to be confusing. You don't have to know that, but just in case you did know that, so I changed it to sugar. And so if sugar dissolves in water, then it must be what type of compound? So water is polar, and like dissolves like, so therefore sugar must be polar. All right, so that takes us to our hydrogen bonds. Okay, so we've talked about ionic. Ionic is due to a transfer of electrons. We've talked about covalent bonds. They're due to a sharing of electrons, which may be equal or unequal. And both of these form the compounds. They form the ionic compounds, they form the molecular compounds. So these are bonds that are forming within the compound, okay? Now, hydrogen bonds, what they're going to do is they are going to form between two different molecules or compounds, and they form between molecules that are polar. So earlier we talked about the weak charges. Okay, when we have polar molecules, they have these partially charged regions. So like here's a water molecule. The hydrogen regions are kind of positive. The oxygen region is kind of negative. And just like we said before, opposites attract. So kind of like with ions, we have an attraction between opposite charges, but they are very, very weak charges, okay? So hydrogen bonds are always represented by little dots because they're not very strong. Covalent bonds are represented by solid lines. And so these hydrogen bonds form between these little weak charges, and they're easy to make and easy to break, okay? So they are very, very, very weak bonds. This is what forms between water molecules, and it's going to be in some very important compounds that we have inside of our bodies. So a lot of times compounds that contain nitrogen, oxygen, or fluorine, these are some of your electron hogs. They like to pull them close. And so when we have polar molecules that have these partial charges, that is when we will get those hydrogen bonds, because those kind of positive hydrogens will bind to the kind of negative regions of another compound. And so once again, this is what forms between water molecules. It gives water many special properties, like being a great solvent. It's less dense as a solid. It has a high specific heat, and it changes temperature gradually. Water is sticky. There's a lot of different properties that come from the fact that hydrogen bonds form between water molecules. Hydrogen bonds are also important in DNA. They hold our DNA strands together. And so that helps because we can go through there and break those bonds to open that molecule up. And if they were strong bonds, that would be a very difficult process. So just to do a quick recap, okay, bonds hold atoms together to make molecules and compounds. If electrons are transferred, it forms an ionic bond. If electrons are shared, it forms a covalent bond. If the sharing is equal, we get nonpolar covalent bonds. If the sharing is unequal, we get polar. And these polar molecules have partial charges. Hydrogen bonds can form between them, and they're a very weak bond that forms between those compounds. All right, so last question for this section, match the bond type with its description. All right, remember those key words. Ionic is a transfer. Polar, okay, now covalent means share. Polar means unequal sharing. Once again, covalent means share. Nonpolar means equal sharing. And those hydrogen bonds are those weak bonds that form between compounds. And that is going to finish up Objective 7.